Okay, looks like we're ready to start. Ladies and gentlemen, today we have Dr. John MacCarthy, Director of Systems Engineering Education, talking to us the state of graduate systems engineering education in the US. A little bit about him. John MacCarthy is the director of the university's systems engineering program. Prior to this, he had a variety of systems engineering leadership roles with TRW, Northrop Grumman, the Institute for Defense Analysis, where he developed and evaluated large complex systems and system of systems. He also served for 8 years as an adjunct professor of systems engineering at the University of Maryland, Baltimore County, and 5 years as an assistant professor of physics at Muhlenberg College. Dr. MacCarthy.
Oh, that's right. I'm using that. Okay, well, thank you very much. It's a pleasure to be here. Yet another month that you're in Incose here. Glad to be giving a presentation. I titled the talk here, "The State of Graduate Systems Engineering in the U.S." It was the best title I could think of. I'm not sure I will actually be addressing everything about the state of systems engineering education, but I'll give it a whirl. So just looking, I'm going to talk about what the purpose is in more detail than just the title here. I'm going to give you a little bit about my background. I'm going to talk a little bit about some Incose initiatives because I'm not sure that everyone here is aware of the current Incose initiatives with regard to education. I'm going to talk a little bit about some data sources and then look at graduate programs in the United States and then some considerations here. So the purpose of this presentation is really to provide an overview of Incose's current education-related activities. It's to take a look at the state of graduate systems engineering in the United States, but really it's more to look at what are some of the considerations associated with developing and maintaining a graduate systems engineering program and what the typical content is for graduate systems engineering programs. I think that will, to some extent, address what the state of systems engineering is. And I'm not just going to talk about the University of Maryland. I'm going to talk about one of the things I did when I became the director was I did a survey of many of the systems engineering programs, and so this is a summary of some of the things that I learned in doing that. My background, I'm not really an engineer, though I play one on TV. I'm actually a biophysicist or a physicist. I don't even have a BS. I have a Bachelor of Arts in physics from Carleton College. I got my PhD in physics at the University of Notre Dame, and I did get a real engineering degree. I did get a Master's of Science in Engineering from George Mason University, and the reason for that is I live in Oakton, Virginia, which is about 10 miles away from George Mason. So it was the most convenient, and it had an outstanding program. A little bit about my professional experience. I spent about 20 or more years working for TRW Northrop Grumman. Up there are some of the job titles that I had while working there. I retired from Northrop Grumman, TRW, to go and work for Institute for Defense Analyses, which I did for about 4 years. That was my third favorite job. And I retired from that to take on my current job, which was my second favorite job. My favorite job was the one I had starting out from graduate school here, which was an assistant professor of physics at Muhlenberg College up in Allentown, Pennsylvania, an outstanding small liberal arts school. And some of the other teaching that I've done is I taught a course in network communications at University of Maryland University College for a couple of years. For 8 years, I was an adjunct professor of systems engineering at University of Maryland Baltimore College, Baltimore County, and then About 5 years ago, I became the director here of systems engineering at the University of Maryland. Education has been something that's always been important to me, and that's why I decided on this talk as opposed to about 3 or 4 others that I could give. So when I was in high school in Elko, Nevada, I was the only male member of Future Teachers of America. So my interest in education goes that far back. When I was when I was in my junior and early senior year in college, I thought I was going to be a high school physics professor. I'm sorry, a high school physics teacher. That didn't work out, so I went on and decided I wanted to get a PhD, and then, found myself in college teaching. The way I got into engineering was that all of my students came back to see me, and none of them went into physics, they all went into engineering, and so I figured I should go and I had a little bit of a crisis of relevance and figured I should go and find out what an engineer does so I could be a better physics teacher. And here I am 25 years later, and now I'm an engineer. So I wasn't sure where to put this. This is some research that I did for helping our faculty at the University of Maryland understand why systems engineering was important, and also to help students understand why they might want to consider careers in systems engineering. I've done this survey a number of times over the past 5 to 10 years. When I did it in the past, I only looked at mean salaries. What I did differently last year was I started to look at number of new jobs posted. Now, I think none of us are probably surprised that, of course, the highest paid is software engineer. I think we kind of suspected that systems engineering was probably up there somewhere. Last year when I looked at this, it was actually reliability engineering came out ahead of systems engineering. And of course, depending on the oil market, petroleum engineers or chemical engineers kind of go up and down there, and they're currently down here in fourth place, okay? But that hasn't changed much over the last 5 to 8 years. What I did differently last year was I took a look at the number of jobs, and this is what really shocked me last year. When I looked on Indeed.com, I looked at systems engineer in the Maryland and Virginia area. Now, what I was expecting to see was that, systems engineering is really important here in the DC area, so maybe there are as many jobs in systems engineering as there are in maybe mechanical or aerospace engineering or something like that. What really surprised me, though, was when I looked at it, and of course, no surprise here, who's the winner? Software engineers, okay? But there were more jobs in Maryland and Virginia for systems engineers than there were all of the other engineering disciplines combined. Let me say that again, okay? How many people find that surprising? Okay, and the reason I put this chart up early in a discussion of the state of systems engineering education in America, okay, in the United States, is there's a huge market out there, okay, that we're just beginning to scratch the surface of, okay? And we may not be doing a good job of making people aware of the education opportunities available, and certainly not making high school students aware of this. As a matter of fact, just 2 weeks ago, I went to a high school that had a senior engineering class, which was kind of an interesting thing, and I gave them a spiel on why they might want to consider being systems engineers. When I showed them this chart early on, all of a sudden the attention really turned on. Now again, when I brief this, I say now, in order to be a systems engineer, when you look at those systems engineering jobs, what they say is somebody who knows Unix and is a systems engineer. Someone who knows telecommunications and is a systems engineer. Somebody who knows mechanical engineering and is a systems engineer. No surprise to us who are systems engineers. That's part of the expected training for a systems engineer. Okay. So let me talk a little bit about some Incose educational initiatives. One of the big ones was, and this is very important from my perspective for systems engineering education, is the development of Incose's graduate reference curriculum for systems engineers, for systems engineering, or GRCSE. It came out in 2012. It was revised in 2015, and we are now in the process of revising it yet again. I will be spending a fair amount of this talk kind of going over that because I figure most of you who are in industry and not education may not be aware of what this is, okay, or what's in here. And part of the state of systems engineering education is that some systems engineering programs are following this. And I think what's happening is Incose is doing a good job of selling this, so more and more systems engineering programs are starting to follow this, but some don't, and especially those that are industrial and systems engineering departments, which is a recent change about 5 years ago, as you may be aware. The Institute for Industrial Engineers changed their name to Institute for Industrial and Systems Engineers, okay? And what then happened was that a lot of the graduate programs in industrial engineering added industrial and systems engineering, but it's not clear when you go in and you look at their curriculum that they really are teaching systems engineering, or that they're following or even aware of GRCSE. So this again goes to the what's the state of systems engineering education in the United States. One of the things that Steve Sutton was very involved with was the development of ABET general engineering criteria. Those were approved, I guess, in early 2019. And while the words systems engineering, is everyone here familiar with what ABET does? They accredit engineering programs as being accredited, and basically if you're not accredited, you really don't count. The general criteria were revised, and some of the, I have in backup slides what that revision is. The word systems engineering did not get into the general criteria for what an engineer needs to know. However, things like requirements, architecture, risk analysis, those kinds of things that are that are systems engineering processes do appear now in the new ABET criteria. So we're, again, making progress in that area. In the last few years, last couple of years, there are no ABET criteria for undergraduate systems engineering programs. So any department can create something called a systems engineering master, or a systems engineering major for an undergraduate degree, okay, and it's okay. What has happened recently is that we've worked to develop some systems engineering specific criteria for undergraduate systems engineering programs. ABET only applies to undergraduate programs. You don't accredit graduate programs. You are not required to, though there's an option to do so. So the status was that we put together some draft criteria and got it approved through most of the related societies, with the exception of the IISE that indicated they needed more time to review those. We submitted it to ABET before the Incose meeting in 2019. Since that time, the criteria have been revised somewhat again. We're hoping that maybe next year we will actually have some criteria for undergraduate programs. And then there's an initiative that Incose is putting, that Incose began at the symposium in 2018, which was developing a framework for teaching systems engineering to all undergraduate engineering students. And to some extent, we're working to tie that up to these ABET general engineering criteria. So in a nutshell, what is it that people need to be telling people about systems engineering in introductory engineering courses? And that goes back to my first slide that showed numbers of jobs and salaries, okay? So I'm going to talk a little bit here about something that may bore the dickens out of you, but it's kind of important to me. And that is, what are some of the things that one needs to consider when you're developing a systems engineering program? And why are systems engineering programs different? Okay, so the things that you kind of need to think about are, who are the customers and other stakeholders, and what are the stakeholder needs? So if you're living in Michigan, okay, you've got a different customer base than if you're living in Washington, D.C. Okay, and so the things that are processes that are being used in the auto industry may not be exactly the same ones that we're used to here in the Washington area. So you need to understand who your customers are and who your stakeholders are. Just my perspective, when I went through this exercise, I decided that I had 2 customers for our program. Okay, one customer was local industry and government, and the other were the students. Okay, so the job of my program is to train students to be ready to go into positions in industry and government, okay, to satisfy the 20,000 jobs a year out there in systems engineering or whatever, okay? But then also it's to help the students realize their career goals in preparing them and making them able to be outstanding performers when they get into the workforce, okay? So that was my understanding of customers and stakeholders. You need to understand, you need to identify what the existing infrastructure and constraints are. So when you go into a university, you have the faculty that you have at the university. And that's what you have to work with, okay? So you have to consider their strengths, their interests, what kinds of things they think are important, okay? Many of whom may not have come from industry, okay? And then you have to often expand your program by identifying and bringing in adjunct professors, okay? You need to identify relevant standards and benchmark programs. You need to determine the types of systems engineering program that's required. And so you want to focus on, well, what's the core curriculum going to be versus concentration areas and electives, again, depending on where you are and what the important industries are in your area, that may change. And then you have to determine what your admission criteria are going to be. So these are things that you need to think about when you're developing an engineering, systems engineering program. And then you need to validate the proposed program that you have, and that entails often bringing in industry to take a look at. It involves going through faculty review committees and those kinds of things. And then you have to implement it, which includes developing curriculum, recruiting faculty, and recruiting students. And then you have to validate the implementation to get feedback on, gee, are we doing the right things? So putting together a systems engineering program, okay, is a process of systems engineering. The system is the program, okay? And the domain that you find yourself in then is you've got the stakeholders, users, and the environment, and you need to understand what those are. So a little bit of systems engineering in here. Looking at students, at least for our program and what I understand from a number of other programs when I've talked with other directors, you have 2 types of students. You have, most programs offer what I would tend to call Masters of Engineering in Systems Engineering, which are for working professionals. Most systems engineering programs like to have students that have a few years of work experience, and that means that they probably have a job, okay, and so they're working as part-time students, and they are at least generally domestic students, US citizens, okay? On the other hand, there are some programs that are open to bringing in students fresh out of college. And our program is we have two programs at the University of Maryland. One that is primarily focused on the working student, and then one that's looking at full-time students who are interested in doing research. Okay? So generally those students are fresh out of an undergraduate program, and what I'm finding, and I think what some other programs are finding, is that for those programs, somewhere between 50 to 80% of their students are generally international students. What we're finding, at least in the professional master's program, is that we're getting more full-time students who are generally international students. So those are some trends that we're finding here at the University of Maryland that I think other schools are finding as well. Are you? A little bit. Okay. So there are a broad, if you go out and you look at schools that say they have systems engineering programs, okay, there are a broad variety of what is meant by systems engineering. There are some that are what Incose would generally call systems engineering programs. But then there are programs in industrial and systems engineering, which when I've gone and talked with some of them, they go, "Sysem what? Incose what? Handbook, huh? Gracie?" And then you have some that have the word system engineering in them, but are preceded by something like control systems engineering, which again would be something that most of us who are have Incose backgrounds would not really recognize as being what we understand systems engineering to be. You have information systems engineering, transportation systems engineering, environmental systems engineering, biological systems engineering, and when you go in and you look at those curricula, again, you don't see what most of us would tend to think of as being systems engineering from the Incose perspective. And then there are programs in engineering systems and in system science and in engineering management. So when you're thinking about what your program is going to look like, these are a bunch of names and foci that you can be thinking in terms of where you want to focus your program. You also have a number of different kinds of degree levels that you need to consider. So you have the undergraduate degree. Do you want to have majors, or do you want to have minors? Many of the systems engineering master's programs have certificate programs, which is basically halfway through a master's. And then you have both a Master of Science and a Master of Engineering in systems engineering, and then there are some PhD programs. If you look at US, what I did here was I looked at US News and World Report, and I looked at the Incose Worldwide Directory of Systems Engineering and Industrial Engineering academic programs. If you look at US News and World Report, they lump together industrial, manufacturing, and systems engineering programs, all lumped in together. If you look at and they only identify those programs that have PhD programs. If all you have is a master's, you don't get entered in there. So you won't find Hopkins and you won't find the University of Maryland in there. Okay? It turns out that there were 92 schools listed there. 81 of them were ranked. 11 of them were unranked. Of the top 50 schools, only about 13 to 17, depending on what you want to be looking at, offered a degree in systems engineering. So that's just, if you're looking through data, those are some things that you come to understand. In the Incose Worldwide Directory, there are 127 schools that they've identified. 39 of them have a systems engineering master's that is a systems engineering master of science or systems engineering master of engineering. 17 have industrial and systems engineering, and 43 have industrial engineering only, okay? So the ones that are industrial and systems engineering, some of them, I would say, really are systems have systems engineering programs as a part of them. Others, I think they've adopted the term systems engineering because industrial engineering sounds so 19th century, okay? The local market. So let me talk a little bit about the local market. At least looking at the Worldwide Directory, I understand there may be some additions to that since the Worldwide Directory came out, but in the Worldwide Directory, let's go back here. Again, systems engineering programs, 39 in the United States. 39 in the United States. In the Maryland, DC, and Virginia area, we have 10 of them. A quarter of the systems engineering master's programs in the United States are in the Washington metropolitan area. This is a tough market. Okay, it's a competitive market. We've got some of the best schools in systems engineering, and not only are there 10 of the 49 in this area, okay, they're some of the best in this area. Okay. So what are some things to, again, if you're trying to think of how to put together a master's of science or graduate program in systems engineering, where do you go to find out what you should stick in your curriculum, right? How do you figure out? Because basically, you can call something a systems engineering you can call something a graduate program in systems engineering and teach basket weaving. Okay, it's not quite that bad, but you can pretty much teach anything you want. The system's in there. Well, everything's a system. Okay, so if you're putting together a systems engineering program, where do you go to find out what you should be teaching? You have, of course, locally the faculty that you are a part of the university of. You say, well, what do you faculty believe systems engineering is and that we ought to be teaching? Okay. We also have industrial advisory boards. We go out and we ask, well, industry, what do you think we should be teaching? We have government guidelines like defense acquisition, university references, and the DAG, the Defense Acquisition Guidebook. We have the NASA references and the NASA Systems Engineering Handbook, okay? Fortunately, we also have a standard for what systems engineering is supposed to be, and it would behoove most programs to be aware of the contents of the standards for systems engineering. And, God bless Incose, we have the graduate reference curriculum for systems engineering, and we have the CSEP certification. And so being aware of what the professional societies believes is adequate for certification purposes, okay, might be a good place to start in thinking about what you might want to be loading up your curriculum with. Okay, so again, one of the things you want to think about if you're going to be putting together a systems engineering program is, so what is a systems engineer? And I think Cassia Coffin's suite did a very nice job in a couple of I can't improve on these. So the systems engineer needs to have broad technical depth. They need to have some technical depth in at least one area, and then as your career develops, you develop additional depth in some other areas, and you need to know a little bit about project management. You need to be a little bit of a scientist, a little bit of a mathematician, and a little bit of an engineer, okay? So this is kind of nice top-level cover as to what you might want to think about having your curriculum focus on. So let's take a look at GRCSE. A couple of different revisions of it. It came out at the same time as the Systems Engineering Body of Knowledge. There were an initial bunch of authors. The current governance is the CERC, Incose, and the IEEE. So GRCSE offers guidance for systems engineering, for systems-centric professional masters in systems engineering, including student skills and knowledge and experience that's assumed, sets of outcomes, set of objectives, guidance on curriculum, content, conceptual architecture to communicate and support implementation of the curriculum, and guidance on program implementation and assessment. It addresses what you need to know coming into a systems engineering program, preparatory knowledge, foundational knowledge for systems engineers, which is the core body of knowledge. You should have concentration knowledge in systems engineering management and system design and development. There are two types of major systems engineering programs. There are programs that tend to focus more on engineering management, and then there are programs that tend to focus more on the engineering side of things, okay? And I'll be providing a couple of examples of those a little bit later, of what's meant by those two different types of programs. And then you should have some domain-specific knowledge with regard to at least one area of specialization. This is the structure of the GRCSE core block. Over here, the knowledge structure, and then comparison to the systems engineering handbook structure here. There's a fair amount of overlap there. If you go into the core block and you look at the core topic areas, you have system topics, systems engineering and management, which are some things that you may recognize here as being many of the systems engineering processes, applications enabling systems engineering and related disciplines. So a discussion of what the difference is between systems engineering, software engineering, industrial engineering, those kinds of things. If you go and, what I'm going to do is I'm going to take a look at, if you go into systems engineering and management here, which is kind of the guts of systems engineering here, this is what it further breaks down into, and it indicates something called Bloom's levels of knowledge for each of these areas. And so if you, foundational applies to both systems engineering management oriented systems engineering programs, and this is system design and development, which are really the more engineering focused side of things. So you need to have foundational knowledge here, and then analysis is the highest level of understanding. It means that you can take the concept, solve a problem with it, and not just solve a problem with it, but be able to critically understand why you use that technique to solve that problem as opposed to some other technique. This is the remainder of it. So these are some of the things that you should be covering in your curriculum. Okay, so let me start out by taking a look at what most of us would tend to look at as being systems engineering programs. They generally have a core that includes systems engineering foundations. They generally cover requirements and architecture somewhere, analysis, modeling, and simulation, verification and validation. Generally, you'll have a number of electives that are supposed to be focused in a domain, at least one domain area, because as we know, as systems engineering, you need to have at least depth in one area. These are some of the common areas that you'll find electives in as you go through these, and then many programs have either a team project or a master's thesis that goes into them. Some common admission criteria here. Again, I think this is pretty standard. You're supposed to have a BS in either engineering, science, or mathematics, or computer science, or computer engineering. Letters of recommendation. Generally, most programs want a GPA of more than 3.0. Many programs really insist on your having some work experience. Some programs, generally the Master of Science, but not the Master of Engineering, require GRE scores, so most programs do not require GREs. And then the kind of coursework that is generally assumed looks kind of like that. So the general structure is that you'll have roughly 30 credits, which runs into about 10 courses. You'll have somewhere between 4 to 6 required core courses, or 5 to 6 required core courses, some kind of capstone experience, and then electives generally focused in one area of concentration. The core courses generally have names that look something like these, or address these. And then the electives and concentration areas really vary a great deal school to school, depending again on what local industry is interested in. Okay, I'm sorry, what local industry and or faculty are most interested in. So what I did here was I put down, we've put together our program outcome objectives. So many universities will, many programs will think about, well, coming out of our program, what do we expect students to be able to do? So these are the set of program outcome objectives that we have for our students. I'm going to first talk about our program, and then for comparison, I'm going to give you a couple of other programs as well. So we have our 5 core courses here. We have a systems concepts and processes. We use a model-based approach where we have students do projects using SysML. We have a course on system trade-off analysis, modeling, and simulation. We have a course on system development, verification, validation, and then we have a course in human factors and in system lifecycle analysis and risk management, which is kind of systems engineering management or project management is also are also topics that are covered in that class. So we tend to follow the common structure there. If you are doing a master's, then you take 2 of your 10 courses writing your thesis, doing research for a professor. And if you're in the professional master's program, you take 5 electives. Your electives can be in the following areas, or if there's an area that you want to self-define. So if you want to do, for example, prosthetic systems engineering, okay, you can define as your specialty area prosthesis development, okay, and take courses from the medical school if you want, okay, to satisfy that area of expertise. As I said, we have a Master of Science program and a professional master's program, a Master of Engineering. That's structured a little bit differently. They take the same courses, the same core courses, and generally you'll find in a class in 621, 622, 623 that on projects you will have some of the students on a given project may be from the professional master's program and some may be from the Master of Science program working on the same team. So they take the same core courses. At the University of Maryland, if you get your master's in systems engineering, you can also get a certificate in one of these areas of concentration. So we have that as an option for students as well. So if you're interested, for example, in systems engineering and reliability engineering, because those are the top two, salary-wise, you can do that at the University of Maryland. Okay, Johns Hopkins, another outstanding program in the area. They have a program in systems engineering, but they also have space systems engineering, system science and engineering, and information systems engineering. Their core courses, again, they have kind of a concepts course, they have a management course, they have a software systems engineering, conceptual design, design and integration, system test and evaluation. So they're not the same courses that we have, but I think you can see that when I talked about what the general core consisted of, same kinds of things. Then you have a project class for the students who are not doing a thesis. So that's the integrative exercise. In our program, the integrative exercise is a part of 623, which is the implementation, verification, and validation course. In that class, the students actually develop a software simulation and they handle the development of that simulation as if it were a software project, okay? And so they go through the entire life cycle as a team project for that course. And when I went to George Mason also had a project course. Okay, and then they have electives from the following, from the areas that you see down there. That's the way that they organize things. Stevens is not in this area. I figured I'd pick a couple of schools that are not in this area. Stevens is another excellent university for systems engineering. Again, if you look down this, you'll see that it's following the same kinds of guidelines that I provided as being a generic kind of outline. Virginia Tech. It comes out of their Department of Industrial and Systems Engineering. Again, this is a variation on a theme. They have two areas of engineering focus, so it's a more technically oriented systems engineering program. George Washington is kind of at the other extreme. We talked about so I think our program tends to be more engineering focused, like Virginia Tech's. George Washington University, another excellent university in the area, they have, if you look down their core courses, it doesn't follow kind of that general format of what we might expect for a systems engineering program. And when you tend to look at their systems engineering focus areas, again, the focus in this seems to be systems engineering management. Okay, so you can have a number of different focuses in your systems engineering programs. I took a look at the University of Minnesota, just pulling one out of the air. They do offer 2 courses in systems engineering and then a simulation course. Okay, so wrapping things up here, I've provided you with an overview of some of the current Incose education initiatives. I've gone over with you what the environment is for a graduate systems engineering program. I've talked with you a little bit about what the Incose initiatives in education are. I've shared with you, given you some background on what GRCSE is, and then talked about what the structure of typical systems engineering programs are, and then the structure and specific examples of universities and their structures. So I have some references here. Questions?
Thank you, John. We got questions, Dr. John MacCarthy?
You forgot UMBC, but besides that, I know you got there. We do have a wealth in this area.
You have an excellent program as well.
But I was wondering about
I was a member of your faculty.
Yeah, that's right. Stevens, Stevens really has this hold for system engineering because DoD gives them money for their research and stuff. Did you find that they do research on education, system engineering education, and is there anything useful coming out of what they're seeing or looking at? Or have they done any reports that deal with education from a system engineering standpoint? Since they're a system engineering center, research center, whatever.
So I know what they've developed is some training material for systems engineering. I don't know of any reports that they've generated on the status of systems engineering in the country as a whole. But that's a good question. Yeah.
Testing, okay. The curriculums that you all are looking at, how many really support the Incose SCP certifications?
It's hard to tell. It's really hard to tell.
Because like you're saying, some of them are more focused on the management side of system engineering versus the more 15288 side of system engineering, I guess I'll say.
Right, and because so I've revised some of the description of our curriculum so that it, and course description so that it becomes very clear that we are Incose compliant, because it is not clear the degree to which different programs have really bought into the graduate reference curriculum in systems engineering. My impression is that Johns Hopkins has, my impression is that George Mason has, it's my impression that UMBC has, just from being more involved and aware of what their curricula are. And certainly Stevens is.
And I could tell you a little bit more about that. It's just that we actually work with Incose, and they look at the exam, and they say, these are the aspects of the exam or the handbook that you need. And we have to prove our courses provide our students that information. So we have to do that matching. So our director of our programs are trying to match that now. And they're hoping once that happens, once you take the 5 courses, you automatically get, well, not automatically, but you fill out the application and say, I took these courses, and you get your ASAP. That's all you get. It's an ASAP. So that's how we link it.
And by the way, just following up on that, so one of the things I talked about that was important in developing a program is doing some validation. And so one of the things that we've done the last year and we'll be doing again this year is we've been offering the CSIP exam. At the end of 621, and about half of our students in 621 end up taking that exam. They're encouraged to take it because if they take it and they pass, they get 100% on their final exam. Okay. Yeah. And what we found was that, first of all, that exam occurs at the time when there's a push to get their projects done and they're getting ready for the final. And so they don't have a whole lot of time to study the systems engineering handbook. What they instead do is they tend to focus on studying the notes from 621. Okay? So that having been said, about 60% of the students that end up taking the CSIP exam ended up passing it the first time. Okay, so I took that as being some validation for the material that we had put into 621. Yeah.
Did you find that there were...
One more. Right, yeah. Go ahead.
So I saw several references to risk management. These days, of course, we're seeing risk and opportunity management,
right.
Exploiting potential positives as well as mitigating potential negatives. Has risk and opportunity management become part of any of these curriculum?
Yeah, in 621 and 626, which is the management course, we do have a discussion of doing risk analysis, and we do have a discussion of the similarity between risk analysis and opportunity analysis. We also have a couple of courses at the University of Maryland that are completely devoted to the area of decision and risk analysis. And actually, one of our faculty members wrote an outstanding book on that is used.
Thank you.
Your chart, as you pointed out on jobs, was surprising, the number of jobs that system engineering area constitutes, particularly in Virginia and Maryland. I was just wondering, did you run across a lot of corporate sponsorship of academic programs, or do corporations tend to just rely on their need for jobs to be the draw?
That's something that's frustrating, especially for university faculty. Let me preface this by saying I spent 20 years in industry, and one of the things that I did while I was in industry was I did a lot of hiring of systems engineers fresh out of school. Actually, they were engineers fresh out of school that I would train to be systems engineers. Okay, and I'm sorry, what was the question again?
I was curious about the corporate sponsorship.
Okay.
For instance, when I went back in the day, long time ago, when I was in college, Georgia Power, for instance, would sponsor a chairmanship, and they would different companies would push money at Georgia Tech, but there were strings attached to it because they were trying to develop the people that wanted to study those programs with the idea that they were going to come back and hire in the industry.
Right, okay, thank you. That put me back on track. So what I was going to say is, for me, when I was a hiring manager, it was a one-way street because I didn't have money to give to the universities. Okay, I was just interested in hiring people. What I know is that University of Maryland, Baltimore County's program was really started by Northrop Grumman. And, right, that was about, 20 years ago, 15 years ago?
Yeah.
Something like that, 15 years ago? And we have an endowed professorship, I think, from Lockheed Martin as well. But again, that was 15 years ago.
And it only continued about 5 years, approximately, and they kind of started the initial students were from Northrop Grumman, almost all of them. Now they're from all over the place. Very few actually from Northrop Grumman.
So one of the things that so faculty find it frustrating that it's hard to get money to support their research, which is really money to support graduate students, from local universities. They feel that they're from local industry. And so they feel that they're generating these students for them, but they're really not getting any support from industry. We had a academic sponsorship program for the Institute for Systems Research that we were always trying to find a little bit of money for to help support the institute. That was really a very difficult thing to find. So I've pretty much given up looking for that. What I've done instead is I've looked for companies that are interested in doing part-time internships for students so that they can work half-time while working on their master's degree. So I'm looking for something that is mutually beneficial. Unfortunately, the faculty don't seem interested in that because it cuts them out. But yeah.
Hi. During your talk, you mentioned sort of a modeling-based approach with SysML. With the push for digital engineering, how do you see that affecting graduate and systems engineering education as a whole?
Let me see. Are you asking how do I see teaching of the SysML types of tools, or?
Or beyond SysML? I mean, just digital engineering as a whole with digital twins and that
Right.
kind of thing. How do you see that impacting education?
So our curriculum is developed to help students get ready to do digital engineering, okay? We work to get it, but that's not something that you can get people to do like that. You've got to kind of get them through baby steps. And so the first issue is getting them aware of how to utilize SysML to structure the problem, okay? The second step is getting them aware to how do you create a system model, okay? The third step is how do you get them to utilize the SysML model to drive the simulation and to pull the information from the simulation back into the model. Okay, that's a move toward digital twins and a integration of and model-based systems engineering utilizing SysML. Does that answer your question? Okay.
So I have a question.
And if I'm wrong,
I've
got plenty of students here to.
You said very early in your talk that it's a lot to do with the domain area that you're in, which area of the country or which city, et cetera. So that would tell me that there is already some synergism between the industries in the area the universities are teaching and the types of courses that the university is going to teach. For example, if I was in a highly military zoned area, I'd be thinking of teaching courses in risk management or high security or cyber security type of thing, which should be a synergistic thing between the school and the company without too much of the companies paying them to do what they want to do. Of course, they'll say, we really like this type of course, or they say, have you got students of that type of course? Or they come to your career fairs and ask for these things. So that would help the university to see, hey, these are the type of courses we should teach, because this is the thing they're asking for, and does it fit into the systems engineering model? Is that a right decision to make?
Right.
Yeah, so it doesn't mean that you don't need to get really people throwing money into it, as long as you teach the engineering courses that are generic enough that can be applied to any industry.
So I think there are two issues with money. There are three issues with money, but only two of them are relevant to this question. The first is faculty like doing research and they like to have their research funded by industry. So that's the first question, okay? I hear that loud and clear from our faculty, okay? The second thing is that the students need help paying for a master's program, okay? So those are the two money issues.
And I could just add to that, UMBC is a little different in terms that we're not as research focused, so it's more of the professional end of things. So in light of that, as you said about the stakeholders, we have a local industry group that, we pull in people from companies. They're almost like an advisory board. Yeah, you remember doing that.
Yeah.
And we'd bring in Northrop Grumman and the Boeings and we just one representative, and we would ask them, are we doing well, and what else do you want us to teach? So that was one way to discuss what you were saying, domains, local areas and stuff.
Right. Now, to be fair, on the money side of things, for students who are working for companies are very generous.
They are.
Okay,
yes, that's right.
in providing, I'm sorry, not all companies, many companies and most of the big companies in this area provide funding for the tuition that we charge and the books.
Yes.
And so that is as I'm thinking about this, that is a very valuable form of industry sponsorship of systems
That's a good
engineering
way of putting
education.
it. Yeah, good. All right.
Okay, thank you very much, Dr. MacCarthy. Big hand.